Okay, suppose that you are in one of the classes and you had an exam, and the exam average was 70 out of 100 and the standard deviation was 10 and you scored 83. However, your friend was in another class and they had the same exam, but the total or the max grade was out of 40, so the average was 30 out of 40 and the standard deviation was 3 and your friend scored 32. And you'd like to know which one basically scored higher, you or him. So what we do, we do something we call standardizing the value. So we would like to standardize our value. Why do we need to standardize? To make sure that we can compare them. In the current situation, we cannot compare your value and your classmate grade. So what we do, we find the standardized value. So we scale that value actually. So the standardized value, we call it the z-value. Z-value. How do we calculate the z-value? The z-value is just your value x. Subtract your x by the mu. So x minus mu divided by the standard deviation. So in your case, your z-value, your standardized value is 83 minus 70 divided by 10, which is 1.3. However, the standardized value for your friend is z equals 32 minus 30 divided by 3, which is 2 over 3, which is approximately 66%. So it's clear that your score is higher than him. So your z-score is greater than him. So you got you performed better than your friend. But we are going to do something else now, because we know that if your teacher said the grades are normally distributed for both classes, normally, or bell curved for both classes, okay. So what can you say about the curve? You can tell me that this is the curve, this is the x, this is 83, this is the other class, this is the curve, kind of, this is the 30, this is the 70, sorry. Right? And your score here is 83. 83 somewhere maybe here. Your friend's score somewhere here. Right? And we can actually, this is normal distribution. This is normal. We can create a special type of distributions. We call it standard normal distribution. Standard normal distribution is very helpful because we can standardize all of the values. We can convert any value, any normal distribution, we can take it to that standard normal distribution. The idea, why do we need to have standard normal distribution? The idea is very simple. Because if I ask you now to calculate the probability of this, what is the probability of x, let's say, you'd like to know what is the percentage of students get less than you. So what is the probability that x less than 83? So we have to do some calculations. What we are looking for this area. Because we said that to find the probability, we're looking for the area under the curve, less than 83. The same thing is applicable to your friend. If you'd like to know what is the area, what is the probability that people get less than him, he's going to go to the area under the curve and find this area. And this involves calculations, basically. Both of them, they involve calculations. Here we have different units. In this example, we have different units than this example. We have two different examples. So to do this, we have to do some calculations. And actually, this is very, very tedious calculations and complicated, and it's time-consuming. So what did we do? We said, okay, why don't we standardize these values? And if we standardize these values, we can construct a distribution. We call it standard normal distribution in this case. And this is standard normal distribution. What does it mean, standard normal distribution? It means that it's normal, it's bell curved, but it has some features. The mean, the middle value is 0. The mean is 0. We will not call it mu, we're going to call it, okay, the mu z, actually. This is 0. Okay? And the standard deviation is 1. Sigma is 1. For any standard distribution, any distribution, any normal distribution, you'd like to take it to standardize it, we are going to have this kind of distribution. The mean is 0, the standard deviation is 1. For instance, instead of doing all of these calculations in each class, what did we do? We standardized your grade, and you got 1.3. What does it mean by the mean is 0 and the standard deviation is 1? So the right-hand side of the mean, we get positive values. Left-hand side of the mean, we get negative values. So for example, if you'd like to look at 1.3, where is 1.3? It's going to be somewhere here. This is 1.3. Again, if you'd like to look at the 0.66, because it's a standardized value, it's going to be somewhere here. So what did we do? We can put both grades in one in one distribution, because this is a standardized distribution. And if you'd like to find now the area, the probability, you can do so. For example, what can you do? You can just tell me that, hey, I'm looking for the probability under the curve. I need to know this region, which is equivalent. This is important. Let me shade it in blue, which is equivalent to that region. Or you would like to know this region, which is equivalent to that one. So basically, if you would like to find the probability of x less than 83 is exactly the same as, because this tells you that you are going to find the area under the curve in that curve, is the same as finding the probability for z less than 1.3. Now, in this x-axis we have x, in this x-axis we have z values, the standardized values, okay? So these are the same. Finding the area under the curve when x is less than 83 is the same as finding the area under the curve when z less than 1.3, because the 1.3 is the standardized value of the x equals 83. So you are going to get the same area, but the first one is tedious calculations, long calculations. This one is standardized one. You can do this one easily, okay? The same thing with what? With the other one. P of the probability of x less than 32 is the same as the probability of z less than 0.66. Either you're going to find the first one from the first curve, or you're going to find the second one from the second one, because it's a standardized. It works for any values. The takeaway from here is what? Any value of the normal distribution has a standardized value. So any x value has an associated z value. If I give you x, you can give me z. Okay? So that's why if we have so many scenarios in the world, we have so many variables are distributed normally. So it's very complicated to do the calculations for each. We graph different curve, and we have different mean. Every time we have different mean. And we do the calculations to find the probability. Then we said, okay, why don't we standardize this? Why don't we every time standardize x to the z value, and we find the area under the curve? And we're going to get the same thing, correct? So this is exactly what we are going to do. The standardized value help you, or using standard normal distribution is much better using the normal distribution. Now, in our case, because we are going to use Excel actually, you can use two different methods. You can use the direct method using the normal distribution, or you can switch from the normal to standard, then use the formulas that related to the standard. Actually, the two formulas basically we use. Actually, Excel do this for you. You don't need to do the conversion yourself, but Excel is going to do this for you. Okay, so this is the whole idea about the standard normal distribution. And as I said, the standard normal distribution has a mean of 0, standard deviation of 1. The horizontal axis is the scaled in z values, right? And we know number of the standard deviations away from the mean, which is 0, 1, 2 here. This is exactly what we said. This is the mean 0. This is 1 standard deviation. This is 1, 2. This is -1, -2, and so on. We talked about the standardized value and how we use the standardized value to construct the standard normal distribution. So this is kind of an illustration about the difference between normal and standard normal distribution. And after that, we are going to use Excel. So let's do an Excel now. So now the goal is to find the probability of x less than 83. And we said this is equivalent to this. Oops, this is equivalent to 1.3. So how to find, okay, the question is to find this, right? How to find, first of all, how to find the z value in Excel. If I give you the x value, if I give you x equals 83, the question is, what is the standardized value for x? What is the z value for x? Just what you have to do is go to Excel, write equals, standardize. Then standardized equals what? The first value you have to put is the mean. In this case, we have the mean is 70. The second value is going to be your value, the first value is going to be your value that you would like to standardize, which is 83. Second value is the mean. Third value is the standard deviation. If you put this, you are going to get the z value. So z equals 1.3. So this is the first thing, how to use Excel to standardize the x value. The standardized x value for the 83 is 1.3. Now, how to find the probability of p of x less than 83? We are going to use a function in Excel called norm.dist. Open parentheses. We're going to do the same thing x value, it is 83, comma by the mean, which is 70, comma the standard deviation, the order is important, comma, we're going to write it true. Then you're going to write the answer. Let me get the answer for you quickly. So this is 83, comma 70, comma 10, true. So what we get, I get 90%. Approximately 90%. So 90% of the people scored less than 83. So your grade is really high, right? Or, because we said that at the beginning, I said these two are equal. So the first method, we immediately use the first function. So the Excel do the conversion, then give you the answer. Or you can tell me, you can take this, because we find the standardized value. Then you can tell me, okay, let's find this. We should get the same answer, right? It is norm dot s standardized dot dest. What is the mean? Or actually, norm dot s dot dest, norm is going to ask you the z-score only. 1.3, then you give me true. Okay? What do you expect to get? Same answer, about 90%. So either you use this one or that one is the same. But if you look at the first method, it's faster because you have to get, you don't need to standardize. So here, if you noticed that, first we standardized the x first, then we found that one, right? So this is an important idea, an important functions that we are going to use. There's one important point that we'd like to stress on. Suppose that you care about what? You care about, so again, every time you have to graph your function to see it. This is your 70 here. Suppose that someone has got 66, and you would like to know the probability that a person is scoring less than 66. So what you do, you can use immediately norm. So we're looking at this area, remember. The whole area is 1%, 100%. Norm.dest. X is 66. Mean is 70. Standard deviation is 10, comma true. What we get? Let me change this. I got 34%, almost. So you have, this area is about 0.34. My question to you, if this area is 34%, what's the area greater than 66? So we're talking about this area. We know that the whole area is 100%, so 100% minus 34% is what? 100%, or 1 in this case, 1 minus 0.34, which is 0.66. So if I ask you what is the probability of x greater than 66, what you have to do is you have to write 1 minus norm dot dest, because this is the point that I'm going to stress on. It's a very important point. The Excel function always give you the area on the left. Area on the left. Excel doesn't give you the area on the right. You have to do the manipulation here. You have to tell me, okay, if you're looking for the x greater than 66, we have to find the area in the left of the 66 first, then we subtract it from 1, because we know that the whole area is 10%, right? Then we get 66% here. Make sense? One more example. Someone scored, let's say, 75 in that exam. And he would like to know what is the percentage of people, what's the chance that he's going to find people scored more than him. So immediately what you do is you go to the graph. This is the mean. This is the 75% here. And he's looking for the right-hand side region. And immediately you tell me, oh, Excel doesn't give me this. Excel give me that one. If I use norm.dest, Excel is going to give me the area in the blue. Then we do 1 minus. So immediately you can tell me this equal to 1 minus norm.dest. So you have to know your area, which area you're looking for. The right-hand side, the greater than, or the left-hand side, the less than. Make sense? So this is 75, 70, 10, true. What do we get? 1 minus. Let me change it here and get the answer. 69%. So to get 1 minus is about 31%, right? These are approximate answers. So this area is 31%. So this is an example about how to standardize the values and how to, again, if you use the other, by the way, if you use the other, if you standardize x and use the norm.s.this is also fine.